Okay, so last time we looked at Quine's arguments against analyticity, his circularity argument, and his revisability argument. I mentioned last time that in this video, we would consider an alternative reason, one that Quine doesn't give, to think that claim 1 is true, the claim that any claim can be rejected by someone who understands it is true. You could think of this as kind of an aside from the main dialectic. But so here's the idea. Take modus ponens, not by name, but by concept. So here's the concept of modus ponens. If P implies Q and P is true, then Q is true. So the statement, if P then Q, P therefore Q, is a valid argument. Is a valid argument. So let's now make that a sentence. So make this thing here a sentence. If P implies Q and P is true, then Q is true. Plausibly, anyone who understands that claim must assent to it. If someone says to you, yes, I agree that P implies Q, and yes, I agree that P is true, but no, I don't agree that Q is true, you might think, that person has demonstrated that they didn't really understand what implication is, that they don't really understand what truth is, or something along those lines. Because it just seems so obvious that if P implies Q and P is true, then Q is true. Put another way, modus ponens seems like an obviously valid form of inference. So the idea goes, if it's possible to reject this claim even though you understand it, then it's possible to reject any claim even though you understand it. This is kind of like the paradigm case of an understanding assent link. Anybody who understands modus ponens should assent to any instance of modus ponens. And now what I'm going to do is point to an example where a famous logician argues that modus ponens fails, argues that in fact, if P implies Q and P is true, and yet Q is false. So the logician Van McGee says, I think modus ponens is not a valid form of argument, and he consequently rejects this claim here, which seems like if anything is analytic, then this claim is. This example, by the way, comes from Timothy Williamson. He's not talking about analyticity, he's talking about understanding assent links, but the point applies equally to analyticity. So here's the example that Van McGee gives. Now, I should be clear, Timothy Williamson thinks that this is a valid argument. He thinks that modus ponens is exceptionless. That is, there's no cases where P implies Q and P is true and yet Q is false. He's not invoking the example I'm going to give to show otherwise. Instead, what he's doing is he's saying, look, the logician Van McGee thinks that this is not true in some cases. And the logician Van McGee clearly understands the meaning of the word if and the meaning of the word implies. And since he clearly understands this statement, but he thinks there's cases where it's false, it can't be true that if you understand this statement, then you must assent to it. And then says Williamson, if anything is such that if you understand it, then you assent to it, it's going to be this. So there are no understanding assent links, and we can take that to go further and say it's just not true that any claim can be rejected by it's true that any claim can be rejected by someone who understands it. So we can take Williamson's sort of example to support Quine's first premise here. Okay, so how does the example go? This is now the example from Van McGee, which, to be clear again, Williamson doesn't think it shows what Van McGee does think it shows. Williamson is using Van McGee not to support Van McGee's conclusion that modus ponens has exceptions, but rather to support the claim that someone can understand this claim and yet reject it, because he wants to say Van McGee understands it, despite the fact that he rejects it. Okay, so here's the example. Suppose it's the eve of the 1980 US presidential election, and there's 3 candidates in the race. There's Ronald Reagan, who's polling at, these numbers are fictional, but they have the structure right. There's Ronald Reagan, who's polling at about 70%. Jimmy Carter, the Democratic candidate, Ronald Reagan, the Republican candidate, is polling at 70%. Jimmy Carter, the Democratic candidate, polling at 29%. And John Anderson, a second Republican candidate who didn't like Reagan and refused to drop out of the race, who's polling at some fraction below 1%, but I'll just write 1%. Okay? Suppose those are the facts. And let's suppose the polls are broadly reliable. Okay? That is, they're not like wildly inaccurate. Now, here's a sentence. Based on these polls, if I asked you, is this true, what would you say? If Reagan doesn't win, meaning win the 1980 US presidential election, if Reagan doesn't win, then Carter will. Well, most people will say that's true. If there's only 3 candidates in the race, and these are the polling numbers, it seems pretty obvious that if Reagan doesn't win, then Carter will. Okay? Think of this in terms of betting behavior. I give you a certain amount of money to bet, but I say you have to bet on at least 2 people. Presumably you'd bet some money on Reagan and then the remaining money on Carter. Okay, so if Reagan doesn't win, then Carter will is something you believe. Now let's look at another sentence. If a Republican wins, then if Reagan doesn't win, then Anderson will. Well, this again seems like it's got to be true. There's only 2 Republicans in the race. So if it's not one of them, then it's got to be the other one. So you should assent to this as well. You should agree with A, you should agree with B. Now, here's a third sentence. A Republican will win. Again, you should agree that that's true, the idea goes. You could stick in probably if you want, but the point is you're trying to predict the future. So a Republican will win. Again, think of it in terms of betting behavior. If I gave you $100 and said, I'll give you 500 if you're right and I'll keep your 100 if you're wrong, who are you going to bet on? You're going to bet on Reagan because you believe a Republican will win. And the reason you believe a Republican will win is because you believe Reagan will win. Okay. I guess I should have put it like this. If I give you $100 and I say you can bet on the Democrats or the Republicans, you'd bet on the Republicans. You believe a Republican will win. So you believe if Reagan doesn't win, then Carter will, that if a Republican wins, then if it's not Reagan, it will be Anderson, and that a Republican will win. That's all plausible. I'm inclined to believe the same. Now, here's how Van McGee puts this together. He says, let's take B there, that if a Republican wins, then if Reagan doesn't win, then Anderson will, and make it a premise in an argument. If a Republican wins, then if Reagan doesn't, then Anderson will. And now let's take C, a Republican will win. Well, this says if a Republican wins, then if it's not Reagan, it will be Anderson. This says a Republican will win. So it follows that if Reagan doesn't win, then Anderson will. Notice this is just a fancy version of modus ponens. The ordinary version says if P implies Q and P is true, then Q is true. This version says if P implies Q, if P implies if Q then R, and P is true, then Q then R is true. So you can think of this as just kind of substituting Q for a complex formula, like R then S. So if P implies R then S, and P is true, then R then S is true. So it's just modus ponens where the Q has a kind of complex formula in its place. So now we have 1 and 2, which seem true. They're just B and C. If a Republican wins, then if it's not Reagan, it'll be Anderson, and a Republican will win. And we get the conclusion if Reagan doesn't win, then Anderson will win by modus ponens from 1 and 2. But here's the problem. If Reagan doesn't win, then Anderson will is incompatible with A. Remember, A says if Reagan doesn't win, then Carter will. Well, if it's true that if Reagan doesn't win, then Carter will, then it can't be true that if Reagan doesn't win, then Anderson will. So by A, we have to reject 3. But 3 was the conclusion from modus ponens by 1 and 2. So that leaves us just one option, which is to say modus ponens fails here. That is, modus ponens is not a valid form of inference. It's not exceptionless. There are exceptions. There are cases where P implies Q, P is true, and yet Q is false. This being one of them. P implies Q, P is true, and yet Q here is false. That's McGee's interpretation. He thinks there are exceptions. Now, to be clear, that's not Williamson's interpretation. Williamson's interpretation is rather kind of in line with Quine. What Williamson says is, look, McGee understands this statement. He uses this argument to try and show that this statement has exceptions. I don't think he's right, says Williamson. I don't think it does show that this statement has exceptions. But that's how McGee uses the argument. So he concludes that this statement has some exceptions, even though he understands it. Well, if any statement is such that it can't be rejected by someone who understands it, then this statement is such that it can't be rejected by someone who understands it. But McGee rejects it even though he understands it, so no statement is such that it can't be rejected by someone who understands it. Put another way, any claim can be rejected by someone who understands it. Okay? So there's another argument for that premise in Quine's argument. Now, in case you're interested and you're wondering how somebody might get out of this, I think the thing to do, you might disagree, maybe you want to hit pause and puzzle on this for a while. I think that's actually a good idea to hit pause and puzzle on this. If we were in the classroom, I'd have you discuss it for a bit. But maybe the thing to do is just this, to say, look, and I'm sort of bumbling so that you can decide if you want to pause and think about it, but let's say you've come back now. Say, look, it's true that if Reagan doesn't win, then Anderson will. And it's also true that if Reagan doesn't win, then Carter will. How can those both be true? Because for an ordinary material conditional like P implies Q, it's true in any case where the antecedent is false. This is how conditionals work. If you look at the truth table for P implies Q, the conditional P implies Q, P arrow Q, comes out true in any case where P is false. The only case in which it comes out false is the case where P is true and yet Q is false. So if P and Q are both true, P implies Q is true. If P is false and Q is true, P implies Q comes out true. If P is false and Q is false, P implies Q comes out true. It's only false when P is true and Q is false. So, if P is true and Q is false. So since Reagan's going to win, if Reagan doesn't win, then Carter will comes out true because Reagan doesn't win is false. And if Reagan doesn't win, then Anderson will comes out true because Reagan doesn't win is false. So those both come out true despite the fact, despite appearances. So they're actually consistent despite appearances, the idea goes. And the reason we get confused, the reason we tend to think that they can't both be true is because we naturally reinterpret if Reagan doesn't win, then Carter will to mean the following. If Reagan hadn't won, then Carter would have. And we naturally reinterpret if Reagan doesn't win, then Anderson will as if Reagan hadn't won, then Carter would have. And if Reagan hadn't won, then Carter would have, and if Reagan hadn't won, then Anderson would have, are genuinely incompatible. But notice that neither of those follows from one. If Reagan hadn't won, then Carter would have doesn't follow from 1 and 2. So problem solved, the idea goes. Now McGee rejects that solution, but I'm just putting it out there in case you're interested. Okay, we'll stop this video there, and next time we'll continue by looking at some upshots of Quine's arguments before moving on to his discussion of the second dogma of empiricism.